Hello everyone. In this video I'm going to talk to you about a prototype that suggests a possible comprehensive solution to wildfires. Now a little bit of background. As we all know and see on the news every now and then, and with a growing trend for the last 2 decades, along with the other hazards that global warming creates, wildfires are a real hazard, requiring practically every country in the world to be prepared for the summer. If some country is not properly prepared, it could end up with a serious damage to forests, human habitat. Also, in the long run, the destruction of forests and the pollution it creates contributes to a snowball effect, which makes the global warming effect even worse. This is the suggested prototype. Now, to illustrate how elaborate and sharp machinery that deals with deforestation already is, and give you a sense of the feasibility of such a vehicle, you can take a look at this harvester. As you can see, the lumber industry has pretty much mastered the harvestation of trees. You see, it will cut down the tree, strip it of its branches. The length of the stem pieces can be conveniently determined. It does everything quite proficiently. However, in a wildfire scenario, when you need to isolate fast a large area from another in order to control the fire, this vehicle will not meet your demands. To find something that will meet these demands, we'll have to look somewhere else. Take a look at this vehicle with a continuous track. You can see its features and abilities. A pretty fast vehicle, can deal with just about any off-road terrain, and able to travel in a really steep terrain. This is a similar model. It's called the Super Tank. As you can see, it's an off-road animal. So imagine we can harness a vehicle like that to cut down in the forest for us in a wildfire situation. As you can see, its abilities are quite amazing. This vehicle is going to be controlled remotely. There will be no live personnel to extract it if it gets stuck or whatever. This is why we have to send something as adapted to the terrain as that and as independent as that. So, to extinguish a wildfire, the firefighters have a range of tools to achieve the goal, and usually the fire will be extinguished by an efficient combination of these tools altogether. The most known tool is to spread water with a flame retardant from the air, but it is just one of the tools. So, methods that firefighters would use on the ground. For controlling a fire that broke out, or simply for the purpose of forest management, firefighters would actually make an isolated area, burn it in a controlled way, so once the fire will get to that area, it wouldn't have any fuel to proceed forward with. In other videos that I've encountered for forest management, the firefighters would make a distinguish between the vegetation that is close to the ground and the trees. Plainly speaking, they get rid of the lower vegetation and keep the trees. Here you can see the work that the bulldozer did to isolate the two areas. Here they are practicing the work manually, and the bulldozer is coming to make sure everything is isolated after the practice. Now about the example presented. The tree is 12 meters high. The height of the vehicle is 1 meter and 65 centimeters. The length is 240 meters. This is the proposed vehicle in a typical terrain conditions it's going to be working in, which is a steep terrain on a hillside. An helicopter on standby with this vehicle in its belly is going to be alerted to the wildfire area. The helicopter will search a quite horizontal terrain and clear from trees that he can land on near the wildfire. The vehicle is going to disembark from the helicopter. If the only safe landing space is too far, the distance will be covered thanks to the supertank's speed that we saw. So as you can see, the vehicle has three arms. One is the chainsaw, one is the arm that pushes the tree, and one is the weight to balance the vehicle to prevent it from flipping over. When we're talking about a crane truck, for example, it has supporting legs, as you can see here. However, due to the steep terrain and the cutting pace that this vehicle is supposed to work in, this is not really an option. So this is the weight that's supposed to balance the vehicle instead. How would this arm work? So the vehicle is supposed to have a computer that controls an independent controller. This controller will calculate in every given moment the overall forces that the two arms are inflicting on the vehicle, and simultaneously will activate the weight arm to compensate and prevent the vehicle from flipping over. These forces will include the weight of the arms according to their operation and the pressure that the pushing arm exerts on the tree before it gets cut down. This would be done automatically without the interference of the person that is controlling the vehicle remotely. The increment of the counterweight by the weight arm will be done either by transferring the weights on it or by opening it wider. The open and close movement of the arm should transfer the weight faster in case of a moment that the vehicle gets out of balance. The routine work that the vehicle should do is getting to the tree, opening, cutting the tree down, closing, off to the next tree, and so on, to isolate that way one area from another. This would be type number one. Now to isolate completely one area from another, we also will have to remove all the bushes and the dry vegetation. That will be type 2 part. The video's idea in general is to suggest a prototype as realistic as possible with as few question marks as possible. This is the reason why the two types are separated. So to simplify things, the vehicle is now separated to two types. Yet in the future, after a couple of generations of these tools, who knows, it might be combined into one. These are other suggested V-shapes. However, if we want to uproot also big bushes on the way, we would have to use the biggest shovel. Type 2 is supposed to have a bulldozer features. It's meant to scratch the ground, uproot bushes, but not much more than that. That's why it should be much less heavy and much faster than a bulldozer, but less fast than Type 1. So, about how wildfires are handled and the advantage of such vehicles. The main problem with wildfire is that you have to catch it in its early stages. Let's talk about the really problematic scenarios. When the wildfire breaks out after a couple of hot, dry months and the wind is blowing, the wildfire would spread really quickly. What needed is to send firefighters to isolate it from all sides really quick. A smaller isolating radius means less work and a greater chances that they will be able to precede the fire before it spreads out. However, to prevent the chance that the fire will outrun the firefighters while working, with the live personnel, this radius can be too small. The advantage of such tool is it can isolate the fire in a smaller radius. There's more chance to isolate the fire, end it quicker, and with less damage. Great burning in the lower vegetation creates high flames that lights the trees. Trees that are burning can create embers that fly in higher and faster winds, which spreads the fire faster. You can see here a blow of wind accelerate the movement of the fire at the low vegetation. That's why there's a need to isolate all the vegetation of one area from another. The trees are expected to fall down inside the isolated area and burn with the low vegetation. That way the fire do not encounter the higher, faster winds which might have otherwise would flew the embers further and break through the planned isolation of the area. This is how vehicle Type 1 is going to operate. It's going to approach the tree in the designated isolation line, open the saw to locate itself in an angle which enables to exert pressure in the right direction, pull out all the arms, exert the pressure in about 35 degrees angle on the tree, or between 22 to 45 degrees, and start the cutting process. Right afterwards, the saw is folding inwards so it will not get entangled in case the tree will accidentally fall on the vehicle, and the same for the weight as long as it's approved by the computer that calculates the balance of the vehicle. On the side of the vehicle, it doesn't show here, but two curtains can close automatically, leaving only the hatch of the arm open. The round shape of the vehicle protects it against trees that might fall on it accidentally. In such a scenario, it can reverse without getting entangled. There will be no live personnel around to cut the branches in case it gets entangled in such an accident. That's why it's best that it would be closed to the maximum at all times. About the weight, as described before, the balance computer can automatically move the weights as shown, or open-close the arm narrower or wider to achieve a safe balance at all times. Eventually, the vehicle closes all its arms and heads off to the next tree. All the process should be carried out automatically in a fast and intensive pace. The aim is an operating person will sit in the firefighter station, will feed in a software the designated isolation route after the vehicle is at the start point, and from then on everything should be carried out automatically, while the operating person is monitoring the work at all time and can interfere and take control manually if needed. All the sensing equipment should be installed inside the vehicle internally so that it would be shielded against heat, falling objects, and so on. How will these firefighter vehicles would operate? The red dot here is a fire breaking out, and as you can see, the wind is taking it in a specific direction. And a helicopter represented here as the white circle will be alerted to the area, and meanwhile an isolation line will be planned according to the speed of the fire expected, the terrain steepness, etc. The helicopter lands where it can and disembark the vehicles. Each of those blue arrows is a vehicle cutting a segment. A possible scenario in the more complicated cases of a dense or too steep forest, the helicopter won't be able to land just about everywhere and might be able to land only in a further spot. Also, the routes to the line can be long due to terrain conditions. In these cases, Type 1 has an advantage over Type 2. It can reach the designated isolation line faster and also can retreat faster. It's likely that Type 1 will reach the designated isolation line faster anyway and start the work sooner, so this time can be used for monitoring. Air footages can monitor if there's a good chance to hold that line, scrutinizing that the fire is not moving faster than expected due to wind changes, the forest is not too dense, the pace of cutting trees is going as planned, and so on. Here the red line is the part that Type 1 has covered already, and the purple spots represent Type 2 on its way. So, if everything is going according to plan, Type 2s can start clearing the same segments and finish the segments together with Type 1. If not, both of the types can retreat and try to hold the new line further from there. Now, in case we worry that the line wouldn't hold and we want a wider isolation line. In that case, we can send more vehicles to operate. Here, this is the first one operating. The second one starts afterwards so that the trees that are falling will not block the first. Same goes for number 3 and number 4. And after them, Type 2 would come to isolate completely, and it's possible to send several of those as well for a thicker isolation in less time. Holding the line. Now, after the vehicles have already finished the whole isolation line. If the fire manages to breach to the other side, the vehicles may try to still contain it with a quick patch on the breach, as represented here. Another thing that the vehicles can do as soon as they finish the line and in case the fire is completely surrounded by isolation line. As you saw in the beginning of the video, firefighters sometimes ignite a fire that they can control. So if a vehicle can drive inside the isolated area and ignite a fire all along the isolation line, then it's fair to estimate the isolation line will be challenged with less severe wildfire than the one that is headed this way because of the whole snowball effect that comes with large fires, which among the rest includes more embers scattered around at all heights and to further distances. That's why it's worth considering such a complementary step as soon as the isolation line is finished, and the fire that will reach the area will find nothing to burn. If the fire is reaching the line, the vehicles can't isolate it, and it's reaching the vehicles, then the vehicles should stay completely closed and do a retreat. Each vehicle should be tested for how long it can stay in a wildfire without getting damaged, and, and this time limit should be taken into account so that a safe retreat is possible at all times. After finishing the isolation line in the path of the main direction of the fire, obviously the vehicle should complete the work and surround the fire with an isolation line also from all sides. So besides the three arms, how this vehicle is going to be built? Whether it's electrical or combustion engine, it's going to have a radiator, regular AC, since also electrical vehicles needs cooling for the batteries and engine. But once it closes against heat, it's a different story. For start on the ceiling, there will probably be a small exhaust hose for hot air in case the vehicle gets overheated to release the heat, so it wouldn't be cooked inside like a pressure pot. Here you can see it in its closed mode. In that mode, the radiator and the AC is going to be close to the outside. What will replace those functions is a separated emergency cooling system. So about the emergency cooling system. Inside each vehicle can be stored a liquid nitrogen container. Once the vehicle closes itself to the outside, the emergency cooling system can expose the material that way or the other in a controlled manner and ventilate the cold air inside the vehicle so that the temperature inside will remain low. For general impression about this material, you can see this guy measures the temperature without the material. Afterwards, they are pouring it in. They are examining how would an air condition on liquid nitrogen would work. You measure the temperature and it drops. Inside the temperature is really low, below zero. Here is a video with another dude doing the same thing. Here you can see the material is in chunks of hail. So, this is the prototype. You can write in the comments what you think, if you liked it, if you think it wouldn't work. I mean, if you can't find reasons why it wouldn't work. These days, for instance, there are drones operating remotely in armies all over the world. Why not invest in such a vehicle that will work remotely and get the wildfires done with, right? Countries seem to invest a large amount of money in army equipment and get perfected in this field, and maybe neglect a bit other problems that if they would have got half the attention, maybe they would have got solved already, right? Okay, see you. Take care and take care of the environment.